Hello everyone, welcome back to my new channel Chemistry Corner by Rachana Gowda. In this channel, I will be talking about a topic related to the chemistry. For more tips and tricks related to the chemistry, keep watching Chemistry Corner. So, today let us discuss the topic quantum numbers. So, these quantum numbers are the address of an electron, and these are certain numbers used to explain the size, shape, and the orientation of an orbital. So, these quantum numbers will mainly tell you about the position of each electron in an atom. It is described by the four set of numbers. And so, there are four quantum numbers which describes the electron in an atom, and they are first one principal quantum number, and it is represented by the symbol n. Second one azimuthal quantum number, and it is also called as an angular momentum quantum number. It is represented by the symbol L. And the third one, it is a magnetic quantum number. It is represented by the symbol M or ML. And finally, the last one, that is a spin quantum number. It is represented by the symbol S. And this spin quantum number, which is only used in the special behavior of an electron, to find the special behavior of an electron. So let us study one by one. First one, it is a principal quantum number, and it is represented by the symbol n. It describes the size of the orbital, and it gives the energy of electron in an orbit. It gives the shell in which the electron is found, and it also gives the average distance between the electron and the nucleus. The possible values of n are 1, 2, 3, 4, 5, etc. So here n is not equal to 0. So this principal quantum number, which is mainly related to the size and the energy of the main shell, so it is represented by the symbol n. And this principal quantum number, it can have any integral value except 0. So due to the increase in the integral value, there will be an increase in the size and the energy in the main shell of the orbit. For example, we know that the nearest orbital from the nucleus is K, L, M and N. So K is the first nearest shell, and L is the second nearest shell, and M is the third nearest shell, and L is the fourth nearest shell to the nucleus. So the principal quantum number of the K shell is n is equal to 1, because it is the nearest shell to the nucleus and its energy will be lowest than the other. For L shell, n is equal to 2. For M shell, n is equal to 3. And for L shell, n is 4. So these n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. These are called as the principal quantum number for the different shells. So this is all about the principal quantum number. So next one, it is azimuthal quantum number. This azimuthal quantum number, it is also called as an angular momentum quantum number, and it is represented by the symbol L. It describes the shape of the orbital, and it gives the subshell in which the electron is located. It also gives the orbital angular momentum of the electron. For the given values of n, the possible values of L are L is equal to 0, 1, 2 and n minus 1. Means that this quantum number, which only identifies the number of subshells and the shape of the orbital. And we know that the subshell of the main shell, it is denoted by S, P, D and F. So we can find out the subshell of the element in the main shell. So if we are taking the first shell, which is having a quantum number n is equal to 1 and which is containing a single subshell, that is 1s. For n is equal to 2, it contains an 2 subshell, that is 2s and 2p. For n is equal to 3, it contains an 3 subshell, that is 3s, 3p and 3d. For n is equal to 4, it contains an 4 subshells, that is 4s, 4p, 4d and 4s. So the values of the angular momentum quantum number will be range between 0 to n minus 1. And third one, it is a magnetic quantum number. This magnetic quantum number, which is represented by the symbol ml. So it indicates the orientation of the orbital around the nucleus, and it is having an values from plus 1, 0, minus 1, like that it will be having an values. What it means that it only tells about the orientation of an orbital in the subshell. Only the orientation of the orbital in the subshell. So it is having an integral value from ml is equal to minus L to plus L, including the 0. And it is having an formula of 2L plus 1. So in this chart you can see the angular momentum quantum number, that is 0, 1, 2, 3, and that is S subshell, P subshell, D subshell and the F subshell. So the number of orbital, so you can calculate by using the formula 2L plus 1. So L, which indicates the angular momentum quantum number. So 2 into 0 plus 1, you will going to get 1. In the similar way, for the P subshell, L is equal to 1. So 2 into 1 plus 1, that is equal to 3. In the similar way, L is equal to 2 for the D subshell. So 2 into 2 plus 1, that is equal to 5. And for the F subshell, L is equal to 3. So 2 into 3 plus 1, that is equal to 7. So the values of ml is equal to minus L to plus L. For the S subshell, the value of ml will be 0. For the P subshell, the values of ml will be minus 1, 0, plus 1. For the D subshell, minus 2, minus 1, 0, plus 1, plus 2. For the F subshell, the values of ml will be minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So this is about the magnetic quantum number, which only tells about the orientation of the orbital in the subshell. Finally, the last one, that is spin quantum number. It is represented by the symbol S. So it gives the direction of the spin of the electron, and the values of the S may be plus of or minus of. Plus of, which represents the clockwise spin, and the minus of represents the anti-clockwise spin. Means that the spin quantum number, which tells us about the orientation of the electron in the space. That is simply the electron rotating in the clockwise or the anti-clockwise direction. So this is only referred by the spin quantum number. So if now the electron is rotating in the clockwise direction, then the spin quantum number will be equal to plus of. In the similar way, if the electron rotating in the anti-clockwise direction, then the spin quantum number will be equal to minus of. You can observe in this picture, that is, if the electron is rotating in the clockwise direction, then it is plus of. If it is rotating in the anti-clockwise direction, then it will be having an values minus of. This is all about the spin quantum number. So we discuss about the 4 quantum numbers, that is principal quantum number, angular momentum quantum number, magnetic quantum number and the spin quantum number. The principal quantum number, which is related to the size and the energy of the main shell, and the angular momentum number, which is used to identify the number of subshell and the shape of the orbital, and the magnetic quantum number, which tells us about the orientation of the orbital in the subshell. So the last one, spin quantum number, which tells us about the orientation of the electron in the space. So today we discuss about the quantum numbers. Hope everybody has understood. Thanks for watching the video.